back to DSP lecture series. In last video we have discussed about analog to digital signal conversion. For converting analog signal to a digital signal, we require three major processes. One is sampling, second one quantization, and third one encoding. And the very first process is sampling. Sampling is a process to convert an continuous time signal into a discrete time signal. In both input and output side of sampling, we are having a continuous amplitude. Only we are changing the time of the input signal at the output side. It means in the input side we are having continuous time and continuous amplitude, and after sampling, at the output of sampler, we are having discrete time and continuous amplitude signal. The representation of the sampled analog signal is x of n ts, where n is nothing but the number of samples and ts is the sampling interval. It is the reciprocal of sampling frequency. So in order to convert such continuous time to a discrete time signal, this sampling process has to obey a theorem called sampling theorem. If the sampling process is not obeying such sampling theorem, then we cannot retrieve back the analog signal at the receiver side. Here at sending end, we are sending some message that is a purely original natural signal what we human can hear. And this is the transmission medium. It is a digital communication. So after some transmission medium, and at the receiver side we will be expecting some message signal, and we human hear only the analog signal. So again at the receiver side we have to convert this digital signal again back to an analog signal. And so in order to receive the signal, and this sampling process has to obey a theorem called sampling theorem. If such sampling process not obeying sampling theorem means we cannot retrieve the analog signal what we have sent at the sending end at the receiver side. So at the receiver side we will be expecting the message what the sender have sent, right? So in order to get the same original signal what the sender have sent through a transmission medium, this process has to obey certain theorems and laws. So for sampling process it has to obey sampling theorem, and if not so we cannot retrieve the original analog signal at the receiver side. And here at the sending side we are having analog. So for a transmission medium we are in need of digital signal. So again at the receiver side we human can hear only the analog signal. So at the receiver side again we are going to convert this digital signal into an analog signal. So that analog signal should be the same as what we are having at the sending side. So in order to match that analog signal both at sending and receiving side, this three process have to obey some theorems and laws. So for the very first process, that is sampling, it has to obey a sampling theorem. So this is the statement of a sampling theorem. A band limited continuous time signal, again I repeat, a band limited continuous time signal can be represented by its sample, and it can be recovered back when sampling frequency fs is greater than or equal to the twice the highest frequency component of the message signal, that is analog signal. So the theorem states that the fs, that is sampling frequency, should be greater than or equal to twice the maximum frequency of analog signal. So we can say this as the highest frequency component of the continuous time signal. So the message may be having many number of frequencies. So among those frequencies we have to select the maximum frequency, and that frequency will be the main component, because based on that highest frequency only we are going to sample this analog signal. So that we have to consider twice the maximum frequency in order to sample the analog signal. So here the key word is band limited and sampling frequency. The band limited in the sense we can make use of the sampling theorem only for such a band limited type of signal, that is band pass signal or low pass signal. So for low pass signal and for band pass signal only we can make use of this sampling theorem. So here the important terms we have to keep in mind is Nyquist rate and Nyquist interval. Here the sampling frequency Fs should be equal to twice the maximum frequency at least. So this condition we are calling as Nyquist rate, and so the reciprocal of this frequency is sampling interval, that is Ts. So it will be equal to 1 by 2 times of maximum frequency, and this is we can say as Nyquist interval. So frequency, sampling frequency is nothing but Nyquist rate, and the sampling interval, that is sampling time, is nothing but Nyquist interval. And these two are very important for solving numerical problems. And here we are having these two type of signals. First one is low pass signal and second one is band pass signal, and such type of sampling theorem is applicable only for these two types of signal. First one is low pass, second one is band pass. And it means if our this two type of signal is being bounded with frequency limits, it will be having both minimum and maximum frequency limit. And for low pass, in the sense we all know that low pass means it is going to pass only the frequency up to this frequency limit, and more than this frequency the signal is going to get stopped. So this is the meaning for low pass signal. Likewise for in band pass we will be having the signal in between minimum frequency and maximum frequency will be get sampled by using a sampling process, and the rest of the signals will be zero. So this is the meaning for having this frequency bound for both low pass and band pass signal. So after F maximum, the signal, analog signal at the end of sampling process will be zero. Likewise, if you are going to have this band pass analog signal, so the message in between 0 to F minimum and in between F maximum to infinity will be zero. So within this frequency bound only we are going to have a sampling. So this is what the sampling theorem tells. So next